of the Pythagorean Theorem. The first proof, these are the two basic proofs that, two different approaches that most everyone uses, okay? Now, first we use similarity here. If you have two angles in one triangle similar to two angles, congruent to two angles in another, then the two triangles are going to be similar. Here we have this diagram. This is your hypotenuse. And this big triangle is a right triangle. Hypotenuse is C. Now, the triangle on the left has angle B in common with the big triangle, and also has a right angle in common with the big triangle. So the triangle on the left is similar to the big triangle. And by the same reasoning, the triangle on the right is a right triangle, and it has angle A in common with the big triangle. So you have that triangle BCD is going to be similar to triangle BCA. That would be BAC. Okay. The hypotenuse of the little triangle, the triangle on the left is A. The hypotenuse is going to be, this is on the left, so the right angle of the little triangle is D, and the right angle of the big triangle is C. And then we also have that the triangle ACD is similar as ACD. The right angle is at C, and the right angle is at D in the little triangle here. That's going to be similar to the big triangle, and the right angle in the big triangle is at C. So all three triangles are going to be similar because similarity is transitive, so, and reflexive, okay, and symmetric. So all 1, 2, and the big one are all similar. Now we stand at vertex B. Here you stand here. You have a little man who's going to stand at vertex B. Okay, and we look at the triangle on the left. We have that. Well, we're going to call this X. Okay, we have to give it and this is going to be C minus X. So hypotenuse to leg that where the vertex is B, and in the big triangle, the hypotenuse and the this X is at B, hypotenuse to leg, and you have hypotenuse to leg in the big triangle. These are all at B. The hypotenuse, the little triangle on the left to the leg, is to the hypotenuse of the big triangle to the leg. This is the leg of a big triangle, but it's the hypotenuse of the little triangle. Now, we can stand now at A. If we stand at A, we have hypotenuse of the triangle on the right is to its leg, standing at A, as the hypotenuse of the big triangle, okay? The hypotenuse of the big triangle is to its leg. Well, B takes the role of a leg of a big triangle when you stand here, when angle A makes up this side with this leg. So here we have these proportions that relate the big triangle to the one on the left and the one on the right by the similarity. This gives you CX equals A squared. This gives you C squared minus CX equals B squared. But CX is A squared, so you get C squared minus A squared equals B squared. And pushing this to the other side, we get C squared equals A squared plus B squared, which is the Pythagorean theorem. Now we do a second proof, which is really part of what this theorem is about. It's about area. It's the square of the area of the rectangle, square on the base, and the square over here, and the square over here. So now, in this proof, this is the standard proof with a little algebra thrown in here. This is by areas, not completely, but partially. You're going to draw a square. I'm going to draw a square. Look at the. I have to draw a square, right? All right. Draw a square. I like to draw a square. This may not be drawn to scale, but we'll do the best that we can. We're going to draw a square here, and this is going to be, okay, we're going to have the side of the square is going to be a plus b. Okay, make it a square here. This is going to be a plus b. We're going to have a plus b. And over here, we're going to have a plus b. And over here, we're going to have a plus b. These are squares, a square. How we connect here, probably best to try to do this. Now, this is your given right triangle. So this is your given right triangle. And these sides are all C. Okay, so we have the area of the whole, which is your big square, is the sum of the area of the parts. How many parts do we have here? We have 5 parts. We have 5 parts, We have 5 parts, and the area of the whole is A plus B times A plus B. The area of the square is the base times height. And the area of the 5 parts in the inside is 4 times the area of each right triangle. So there are 4 right triangles. So it's 1/2 AB is your area of your right triangle. But then what is this? Is this a square? Or is it just a rhombus where like a diamond in the sky? So we want to know, what about this angle here? And call this angle like gamma. And what kind of angle is it? Is this a right angle? Well, you have the acute angles of a right triangle are complementary. They add up to 90 degrees. So what's left over is going to be gamma. It's going to be a right angle. All these 4 angles are right angles. So let me fix the technical difficulties here. So the area of the rhombus in the middle it's a square though. So the area is C squared. So we have A, this is going to be by FOIL. So it's going to be A squared plus 2AB plus B squared. This is going to be equals 2AB. Okay. This is going to be C squared. So we have A squared. These are going to cancel. And so we have a squared plus b squared equals c squared. So don't forget to hit the like button and subscribe if you want to see more content, because that's the Pythagorean theorem